Okay, we're going to step back. We've been looking at linear and nonlinear functions, and now we're going to look at a very specific type of nonlinear function called an exponential function. So what is an exponential function? Well, when we write an exponential function, it is one where the input, which is our x value or our domain, is actually in the exponent of the function. And on linear, we had a constant rate of change by adding or subtracting the same each time. Well, in an exponential function, it is one where the rate of change is a constant ratio. That means we are going to be multiplying or dividing the same thing each time. Okay, so the standard form of an exponential function looks like this. Y equals a times b raised to the x. And notice that we have our y and our x just like we do with the linear function, but our x is in the exponent. The other parts of this equation are a, which is, if you were going to graph this, would be your y-intercept. And remember, that's the value of y when x is 0. And in a word problem, that would also be like your starting point or your initial amount. The b part of this is what we're going to be multiplying as our constant rate of change. And we call that our constant ratio. So if that b number is larger than 1, like 2, 3, 4, whatever, then that would represent growth. And we saw that in our last unit. And if we graphed it, we'd start off kind of slow and then we go up very rapidly, very much like COVID has been this year. And if that b is bigger than 0 but less than 1, so it's some sort of fraction, that's going to represent decay. And if we did that on a graph, it'd come down very quickly and then it would level off. All right, so when we are looking, let's just go back on that. When we're looking at an equation, if the x is in the exponent, we know that is an exponential equation. Now, when we're looking at a graph, if it starts off slow and goes up very rapidly, that is exponential. Or if it comes down very quickly and then flattens out, that is exponential. The first one that starts out kind of slowly and then goes up quickly, if we look at the equation for that, we could say that, we could rewrite that and say instead of y equals 3 raised to the x, we could say y equals 1 times 3 raised to the x. Then we would know that our graph should cross at 1 because that's our y-intercept, and our ratio of change is 3 because it is greater than 1. It is growth, and we're going to, it's a constant ratio where we're multiplying by 3 each time. On the second graph, this is decay, where it comes down rapidly and then flattens out. If we rewrote this equation, y equals 1 to the 1/3, 1 times 1/3 raised to the x, then again we could identify that our y-intercept was 1 and our rate of change is less than 1 because it's 1/3. And so our constant rate of change is we are dividing by 3. When you multiply by 1/3, that's the exact same thing as dividing by 3. All right, so if we're looking at a table, how do we tell if it is exponential? Well, if my x values go up by a constant amount, they're adding the same amount or subtracting the same amount each time, and then my y values are being multiplied or divided, then that is an exponential table. So in this case, my y values are being multiplied by 4, so this is growth, and the constant ratio is times 4. On the second table, again, my x values are all going up by 1, but look, my y values are going down. And what I'm doing each time is I'm dividing by 5. So remember we said dividing by 5 would be the exact same thing as multiplying by 1/5. So my constant ratio would be 1/5. times 1/5. So again, this is an exponential table. So if your x values are going up or down by the same amount, and your y values are either being multiplied or divided by the same amount, then you have an exponential table. All right, now, the next thing I'm going to ask you to do is graph an exponential function by creating a table. So I've given you the function f of x equals 3 times 2 raised to the x. And I'm actually going to give you the x values to put in here because it starts going up pretty fast. So I'm going to say use 0, 1, 2, and 2.3. And we're going to round to hundreds. All right, so if I put 0 in 3 times 2 raised to the 0, I'm going to put that in my calculator, and that gives me 3. Now, if you do not know how to put in an exponent other than 2, please see one of your teachers. We will show you how to do that on your calculator. If I put 1 in 3 times 2 raised to the first power, that's going to give me 6. If I put 3 times 2 raised to the second power, that's going to give me 12. And if I put 3 raised to the 2.3, that's going to give me 14.78, so almost 15. So I'm going to plot these points now. There's 0, 3. There's 1, 6. There is 2, 12. And there is 2.3 and 14.78. And then I'm going to try to gradually, gracefully draw a line and can see that this is an exponential equation. Okay, there is not specific homework for this concept. So you're going to go to the next concept and go through it, and it will use all of this information.